For this lesson, we're going to talk about solving quadratic equations by factoring, but let's talk about what quadratic means. Normally, we deal with linear equations. I'm going to go into linear, and then I will take you to quadratic because I want you to see the difference between the two. This is a linear equation. It has a degree of 1. The highest degree is 1. For instance, here, the exponent on the y is 1, and the exponent on the x is 1. So out of all three terms, even the 2's a term, y, the x, the 2, those are three terms. Out of all three terms, the highest degree among the three terms is 1. So we say it's linear. But if you graph a linear equation, so say for instance we make x equal to 0. Well, if you put a 0 in here, 0 plus 2 is 2. So 0, 2 would be about right here. If you made x equal to 1, instead of x plus 2, it's 1 plus 2. So we will end up with a 1, 3. An x coordinate of 1 and a y coordinate of 3. This was an x coordinate of 0 and a y coordinate of 2. Okay, so 1, 3. If you put in an x of negative 1, we would get a y of positive 1. So negative 1, positive 1 would be about right there. But if I take these and connect those ordered pair, it makes a straight line. That's why we say it is also linear. It forms a straight line. Okay, but a quadratic equation is an equation where the highest degree isn't 1, but the highest degree is 2. For instance, here you have 1, 2, 3, 4 terms, and of those 4, this has a degree of 1, this has a degree of 2, this has a degree of 1, and this at 3 has a degree of 0. Well, the highest degree in that whole equation is 2, so we say it's quadratic. Of course, we learned this when I introduced polynomials. Okay, so with all that being said, that's why we call it quadratic. But what do they look like on a graph? So let's take a look. So what I'll do is I'll start off with maybe an x of 0 and see what I get for y. So this becomes 0 squared, which is 0. And this becomes 2 times 0. And let me do it up top. So this is 0 squared plus 2 times 0 minus 3, which is, you end up with a y of negative 3. So 0, negative 3. All right, let's try 1. So let's try an x of 1. So we have 1 squared, and I'm going to bring this up. One squared plus 2 times 1 minus 3. Well, 1 squared is 1, and 2 times 1 is 2. 1 plus 2. 1 plus 2 is 3, but 3 minus 3 is 0. So when you put in the x of 1, you get a y of 0. That's 1, 0. All right, let's try an x of 2 and see what we get. So I'm going to say 2 squared, okay, which we know is 4. And I'm going to erase this all together. 2 squared is 4. And then plus 2 times 2 minus 3. But 2 times 2 is 4, so that's plus 4. And then minus 3. That's going to be 8 minus 3, which is 5. So I'll get a y of 5, 2, 5. And let me put my 2 a little closer. 2, 5. 1, 2, 3, 4, 5. Okay. I can see that this is getting bigger and bigger. So let me see what happens if I go on this side. Instead of an x that's positive, let's try an x that's negative and see what happens. So let's try an x of negative 1. So we're going to end up with negative 1 squared. A negative 1 times negative 1 is simply 1. Plus 2 times negative 1, which is negative 2. And then minus 3. Well, that's just going to end up being negative 1 minus 3, which is negative 4. Negative 1, negative 4. So now we're going to go down. All right, and we're going to be right. Sorry. All right, hold on, guys. We're going to be right here. And I'm just double checking this because something looks off to me for that. Positive 1, negative 2, negative 3. Okay, let's try negative 2. Let's try an x of negative 2. Okay, negative 2 times negative 2. Well, negative 2 squared is positive 4. Plus 2 times negative 2, which is minus 4, and then minus 3. So that's 0 minus 3, which is negative 3. All right, so 0, negative 3. That looks familiar. Okay. Let's try an x of negative 2 and see what we get. Oh, we did the negative 2. Let's try an x of negative 3, sorry. For the negative 2, we got negative 4. So I'm going to go back. We got negative 3. Yeah, let me go back. I didn't write that down. So for an x of negative 2, we got a y of negative 3. Okay, we also got a y of negative 3 here, y of negative 3 there. Okay, so let's try an x of negative 3. All right. So I end up with negative 3 squared, which is 9, plus 2 times negative 3, which is negative 6, minus 3. Well, that ends up being 3 minus 3, which is 0. All right, negative 3, 0 to the left, 3, and stay right there. So let's take a look at the shape, what's happening. So I got a y of 0 right here, y of 0 right there. Okay, so let's see what's going on here. Let's try x of negative 4. I can guarantee you it's going to be right here. About right in there. Because it looks like these dots here are equidistant from each other. These are equidistant. Like they could be split. Okay, but let's check and see. I think I'm going to get a 5. All right, so let's try an x of negative 3 and see if that's actually what I get. Well, x of negative 4. Okay. So we'll end up with negative 4 squared, which is 16, plus 2 times negative 4, which is negative 8, minus that 3. Well, that ends up being 8 minus 3, which is 5. And there it is. Negative 4, 5. So we're going to take a look at this shape. So I'm going to connect these dots and see what it looks like. All right, so this looks like a U-shaped figure. It is. It is a U-shaped figure. So if it's quadratic, it's going to form a U shape, not a straight line. It's also going to have symmetry to it. When I say symmetry, I mean if I were to fold it in half at a certain line, one side would be symmetrical to the other. And that line would be the x of, let's see, negative 1 right here. An x of negative 1. It's not really part of your graph. Let me do it in a different color. This is not really part of your graph, so I need to dot the line to make it where it's not really part of my graph. It's just showing me where if I would fold it, well, one side would flip over and be the same as the other. And as you can see, these dots are equidistant from the axis of symmetry. They call it the line of symmetry or axis of symmetry. And this point here at the bottom is called our minimum because it's the smallest value on that graph. And it's also called the vertex. Okay, it's actually the point where your graph begins to turn. So from left to right, this graph goes down, and then at the vertex, it begins to turn and go back up. All right, but this whole thing, this whole graph is a U shape, and it's called a, not parabola, but a parabola. So all quadratic functions form what we call a parabola or a U shape on a graph. Now that U shape can be turned upside down or it can be turned upright. When I say upside down, it can be turned like this. And instead of having a maximum for your vertex or turning point is, instead of having a minimum for your vertex, this is a, what we call a maximum because it's the highest point on the graph. Whereas this one is called a minimum because it's the lowest point on the graph. But I just wanted to show you what a quadratic equation looks like. But what we're going to be doing specifically is looking for what we call the roots or zeros of the function. Basically, when I say the roots or the zeros of the function, it's going to be the point of intersection with the x-axis when graphed. Okay, these points of intersection are called x-intercepts, guys. They're called roots, zeros, or solutions. All of them mean the same thing. All of them mean whether they intersect the x-axis. That's all that means. If I say, what are my roots or what are my zeros of the quadratic function, I just want to know where does it intersect the x-axis if I graph it. So if I ask you all on this particular graph, where does this graph intersect the x-axis? Well, this is the x-axis, so it intersects it right here at an x of positive 1. And it intersects it right here at an x of, well, that's 0. So that's 1. Let me put it in purple. 1, 2, or negative 3. So it intersects it at an x on the x of x-axis right here. That's an x of 1. And this is an x of negative 3, guys. So that's what I call my roots or my x-intercepts. So those are my solutions. But I won't do a whole lesson on graphing. It was just an introduction. The lesson I want to do is how do you find the roots or the intercepts without graphing, but by factoring. So what we want to do is actually find those roots or x-intercepts, which is where it crosses where our graph, when graphed, or our equation when graphed, would cross the x-axis. Where would it cross the x-axis? But we don't want to do it by graphing now. We just want to do it by factoring, okay? All right, so I'm going to go here. It says determine the x-intercepts or roots or zeros of the graphed quadratic function. So I already graphed this one for you. So you're just going to look and see where it crosses the x-axis. So it crosses the x-axis here. So it's 1. And you got another x of 5. That's where it touches the x-axis. Now that's easy to do, especially if it's already graphed for you. If it's not already graphed, you'll practice this again when you get to Algebra 2, guys. You'll practice graphing. Sorry, I didn't have enough time to go into depth in this particular section. But I do want to go into depth on how do you solve them and find those that the x-intercept, one x-intercept is 1 and one x-intercept is 5 when graphing. Not when graphing, but when factoring, I'm sorry. Okay. All right, so if I were to take the same equation, y equals to x squared minus 6x plus 5, but I said I wanted to find those roots by factoring instead of graphing, how would you do it? Well, let's take a look. So this has an x of 1, but we're going to talk about what the y is. That coordinate for y is 0. That's the point 1, 0. This has an x of 5, but the y is also 0. So basically, guys, you can find any x-intercept when your y coordinate equals 0. So what I'm going to do is take this y and set it equal to 0, and then I'm going to solve for x. But I'm going to solve for x by factoring, okay? To figure out, to get these values. Okay, so basically what I'm saying is if I didn't give you the graph, you could use factoring to solve. All you have to do is set y equal to 0 and solve for x. And you do that by factoring. Well, take a look at this x. Look on this side right here. This x has a leading coefficient of 1, and it's a trinomial. So I'm going to use what I call the easy x and put my 5 and my negative 6. And I just think to myself, what gives me 5 when I multiply, but yet negative 6 when I add? So that would be negative 5 times negative 1. Negative 5 times negative 1 is positive 5, and negative 5 plus negative 1 is negative 6. So basically this ends up being 0, and in factor form, remember, if it's the easy x, those actually become part of your factor. So you write x minus 5. They don't break up the middle. They just become part of your factors. X minus 5 and x minus 1. Well, that's still not going to give us an x of 1 and an x of 5. So what do? Well, you have two factors here. You got x minus 5 is one factor, and x minus 1 is another factor. What you do is you take each one of those factors and set it equal to 0. And then you solve. Plus 5 on both sides. So x is equal to 5. That gives me one root. Add 1 to both sides here. That gives me the second root. I'm going to put another. Okay, another root. Let me make that look a little better. Now, you won't always have two roots or two x-intercepts. These are x-intercepts. When I say roots, guys, I'm talking about where my graph will touch the x-axis, which are my x-intercepts. You won't always have two. Sometimes you'll just have one. Okay, so let's take a look at the note. To solve by factoring, what do? Well, we set the equation equal to 0 first because our y has to be 0. Because on the graph for an x-intercept, the y is always 0. B, you want to factor. And you can use that graphic organizer I gave you too. C, you want to set each factor equal to 0 and then solve for x. All right, it says write your answers in curly braces, so you can write it like so. My x-intercepts are 5 and 1. You could have also written 1, 5. I don't care which one you put in there first. All right, so let's practice doing that, okay? So we're going to take a look at this graph real quick. Because the leading coefficient is negative 1, this graph is turned upside down, as you can see. On this one, on 1A, the leading coefficient was positive 1. So the graph was open upward. Here the graph opens downward. Because the leading coefficient is negative. This one opens upward because the leading coefficient is positive, guys. Got something to do with that leading coefficient, the way it opens. All right, but as you can tell just by looking at the graph, and I've already graphed it for you, my x-intercepts are negative 3 and positive 1. Just by looking at the graph, that's why it touches the y, where it touches the x-axis. All right, but if I want to solve this using a factoring method, Then I'm just going to write y equals to negative 1 x squared minus 2x plus 3. And I'm going to set this equal to 0. And because my leading coefficient is negative, it's like a negative 1, I am going to factor out that negative 1. I want it to be a positive 1. So I'm going to divide each piece by negative 1. So I can focus on the remainder only, okay? Which will have a positive 1. So that's going to give me negative 1 divided by negative 1 is positive 1 x squared. That's going to be positive 2x minus 3. So all I did was factor out the negative. Now I simply want to focus on this part right here. Now there's my x, and it has a leading coefficient now of a positive 1. So I'm going to focus on that. Negative 3. What gives me negative 3 when I multiply, but yet 2 when I add? That would be 3 times negative 1. I'm sorry. Yeah. 3 times negative 1 is negative 3. And 3 plus negative 1 is positive 2. So these become, because this is the x with the leading coefficient of 1, these numbers on the sides of the x actually are my factors. So I write x plus 3 times x minus 1. Now what I want to do is take each one of my factors. When I say take each one of my factors, not the GCF, not the 1, not the negative 1 I factored out. But I'm talking about factors that contain x. If you're going to solve for x, you need the factors that contain x. So any factors that contain x, or whatever variable is being used, must be set equal to 0 in this step, okay? Now, if you got a factor that doesn't contain x, don't worry about it. Like, this factor doesn't contain x. I'm not going to worry about it. So I'm going to take x plus 3, because that factor does, and set it equal to 0, and x minus 1 and set it equal to 0. Sorry. And then I'll solve. I'm going to subtract 3 from both sides. So I get an x of negative 3, which matches that one, or matches that on the graph. And then I'm going to add 1 to both sides. So he'll get an x of 1. So those are my two x-intercepts, or my roots. There's that positive 1. That's where my graph will cross the x-axis when graphed, okay? But I'm doing it by factoring. Okay, I want you to pause the video, and you're going to try this one. Oh, okay, so you should be able to see this. The only place that it crosses the x-axis is at negative 2. That's it. It only crosses the x-axis at negative 2. And this doesn't have 2 intercepts. It only has 1. So I'm going to go back up here. This is what we call, when it has two intercepts, it's called a double root. A double root, again, root just means x-intercept, so it's 2 intercepts. This had a double root because it has double root, because it crossed the x-axis in 2 spots. But this isn't a double root. It's just a single root, guys. Just one. All right, so let's see if we can take this and solve it by factoring. See if we can get that x equal to negative 2 by factoring. All right, and they're both what they call distinct roots, which means you can tell exactly where they are. You don't have to estimate them, okay? So you can have one distinct root. You can have 2 distinct roots. Distinct again meaning that you can name them. You don't have to estimate or try to guess what that x-intercept is. Because sometimes you might have an x-intercept that might be right here and right there, but you don't know. You can't really name those because they don't lie specifically in a whole number integral, okay? Or the opposite of a whole number, like negative 1, negative 2. Okay, let's get back to factoring this. Set this equal to 0. It's a leading coefficient of 1, so I'm going to use the easy x. That's going to be 2 times 2. So we'll end up with x plus 2 times x plus 2. This is also a perfect square trinomial, guys. I could have looked at it that way. Alright, so here are my factors, x plus 2 and x plus 2. But if you'll notice, they're the same. So you don't want to write x plus 2 equal to 0 twice, because you're just going to get the same number again. So you just write it once when they're the same. When they're the same and you only have to write it once, that's how you know you're going to get a single root. Here, these were not the same. That's not the same as that. That's how you know you're going to get a double root, okay? All right, so all we want to do right now is just solve the rest of these by factoring. And you could put this in curly braces if you want to. Let me go back. It's only one root, though, or one x-intercept. All right, solve each quadratic equation by factoring. So we're just going to be using the graphic organizer for this case, all right? Okay, the very first thing you should be looking for when you're going to solve by factoring is for GCF. So on number 4, there is no GCF. There's a leading coefficient of 1, so I'm going to use the easy x. That's 25 and 10, so that should be 5 and 5. So, and I've already set these equal to 0, guys, so you don't have to worry about that. So we end up with x plus 5 times x plus 5 equal to 0. I'm going to end up with a single root because they're the same. So I just take one of those and set it equal to 0. And when I solve, my one root is x equal to negative 5. So if I were to graph this, the vertex or the tip of my graph would be at negative 5, 0. When it touches it at one spot, that means that's the vertex touching it, okay? When it's a single root, that means the vertex is touching the x-axis. When it's a double root, it means something other than the vertex, because the vertex is up here. When it's a double root, something other than the vertex is touching it. Like the sides, one half of my graph and the other half of my graph, but not the vertex, okay? All right, so here, 5, look for a GCF. I don't see a GCF. So I'll be using the easy x because that's an understood coefficient of 1. Negative 27 and 6. That would give me 9 and negative 3. X plus 9 times x minus 3. My two factors are x plus 9 and x minus 3. So I'm going to end up with a double root on this one, okay? Because I have two different factors. Subtract 9 from both sides, so I end up with x equals to negative 9. Add 3 to both sides, so here I end up with x equals to 3. If I were to graph that equation, it would cross the x-intercept at my parabola would cross the x-intercept at negative 9 and 3. Okay, let's take a look at 6. You're looking for a GCF first. There is one. The GCF here is 3x. So I'm going to divide each by 3x. So we end up with 3x equals to x plus 5. All right, so you always check your remainder to see if you can factor it. This is my remainder, but you can't factor x plus 1. It's a binomial. Your graphic, or it has two terms, which means it's a binomial. But your graphic organizer tells you if your remainder is 2 terms or you're dealing with 2 terms, you should check it for a difference of 2 squares. X plus 5 is not a difference of 2 squares. So what I'm going to do is proceed to take each factor that has an x in it, and this factor has an x in it, and the remaining factor has an x in it. So I'm going to take each one and set it equal to 0. 3x equal to 0, and x plus 5 equal to 0. So I'm going to divide both sides by 3. I get an x equal to 0. And here I'm going to subtract 5 from both sides. I get x equal to negative 5. So my two roots, or x-intercepts, are 0 and negative 5. All right, you're going to pause the video and try 7. And I've already set everything equal to 0, guys. Okay, this is what you should have. There is a GCF 2x. So we end up with 2x equals to 4. 4x minus 3. And you're going to check this term to see if you can do anything with it. You can't. It's two terms. It's not a difference of two perfect squares. So you just stop and set each term with an x in it equal to 0. So this term also has an x in it. I'm going to set 2x equal to 0 and then 4x minus 3 equal to 0. You're going to set both of those factors equal to 0. Divide both sides by 2 here. So one of your roots or intercepts is 0. X intercepts is 0. This one is a basic two-step equation. So I'm just going to add 3 to both sides. I get 4x equal to 3. I'm going to divide both sides by 4. And one of my x-intercepts is 3/4. So 0, 3/4. Those are my two intercepts, guys. Okay, so you're going to take a look at 8. First of all, you're looking for a GCF between 60x squared and 64. There is none. So you can proceed to your graphical organizer. What do you do if there are two terms? Well, you check it to see if it's a difference of two perfect squares. This is a difference of two perfect squares. X squared is a perfect square. 64 is a perfect square. And your graphic organizer tells you all you do to factor the difference of two perfect squares is take the square root of the first term, which is square root of x squared is x, and the square root of the second term, which is 64. Square root of 64 is 8. And write those factors as a sum and a difference. Using those results, x plus 8, x minus 8. There's my sum, there's my difference. Then I'm just going to take these two, set them equal to 0. Here I'm going to get x equals to negative 8. And here I'm going to get x equals to positive 8. So my intercepts, my x-intercepts would be negative 8 and positive 8. Okay, let's take a look at 9. 9, you're looking for a GCF, but there is no GCF between 9 squared and 49. So you just figure out, well, I got two terms. My graphic organizer tells me to check two terms to see if it's a difference of two perfect squares. It is, sorry. Okay, so 9x squared is a perfect square. So the square root of it is 3x. 49 is also a perfect square. Square root of it is 7. So I'm going to write one as a sum and one as a difference using those two terms. And I'm going to set each term equal to 0. If I solve this two-step, I end up with 3x equals to negative 7. Divide both sides by 3, and x is equal to negative 7/3. Here, if I add 7 to both sides to solve this particular equation, I end up with 3x equal to positive 7. Divide both sides by 3, and x is equal to positive 7/3. So I'm going to do something. I'm going to write my answer like this to show you that it can, if you got the same number just with opposite signs, you can put plus or minus then that number. You could have also written it like this, 7/3 and negative 7/3. But I'm going to go back over here. Since this was negative 8 and 8, you could have written it as plus or minus 8, which tells me positive 8 and negative 8 are both my solutions. So you can write it like this or like that if the numbers are the same but the signs are opposite, guys. All right, so let's look at equations that are not in what we call standard form. Standard form is when you have your highest degree, and then your next highest degree, and your next highest degree. In other words, it goes from high degree to low degree when your equation has the terms in highest degree to lowest degree. Okay, so if your equation is not in standard form, just put it in standard form. So make sure you set it equal to 0. You're going to have to move some terms around and then factor and solve. When you move those terms around, please put your equation in standard form. Okay? And it's got to be set equal to 0, guys. Please make it equal to 0, because you can only find an x-intercept if your y-coordinate is 0. The y has to be 0. So you got to set these things equal to 0, okay? If you're not setting these equal to 0, then you're defeating the whole purpose of finding the x-intercepts. So I'm going to set this equal to 0 by subtracting 21 from both sides. So I end up with x squared, keep it in standard form or descending order, x squared plus 4x minus 21 equal to 0. Okay, that's set. And there's no GCF there, so I'm just going to go with the easy x. Negative 21 and 4. That would be negative 3 and positive 7. So we're looking at x minus 3 times x plus 7 equal to 0. And then we just set each one of those factors equal to 0 and solve. So here you're going to get an x-intercept of 3. Here you'll get an x-intercept of negative 7. Now 11 on the other hand, that's not set up with anything on it, so we're not going to do that problem because I didn't set it equal to anything. Okay, so I'm just going to say that's a bad problem. And right now I don't feel like making up anything, because it should have, if we're going to be looking at when it's not in standard form, I need to put an equation or equal sign in this, so I messed that one up. All right, let's go on to 12. All right, I got to get this thing in standard form. I got to get it set equal to 0. So I have an x squared here and an x squared on the other side. So I don't like to keep my coefficients, my leading coefficient positive, guys. Okay, I don't like my leading coefficient to be negative, because if it's negative, I'm going to have to factor out a negative 1 in order to make my leading coefficient positive, and I don't feel like doing that. So I always try to keep my leading coefficient positive. You don't have to, though. It's just if you don't, you're going to have to factor out a negative 1 in the end. I'm going to put LC for leading coefficient, POS for positive. So that means I don't want to subtract 11x squared, although that would make this side 0 very easily. But it's going to make this negative 10x squared. My leading coefficient will be negative, and I don't like that. Okay, so I'm not going to do that. I'm going to make this right side 0. So I'm going to subtract 11x squared here. 1x squared. So that's going to give me 10x squared equals to 8x. But now I don't like that either. So I am going to subtract 8x from both sides. So I'll end up going to unstack these. It'll look better. Unstack them. So I end up with 10x squared. Keep that leading coefficient positive. 10x squared minus 8x equals to 0. Now I got it equal to 0. And I see that they have I'm going to have to go up here. I see that there's a GCF. The GCF here is 2x. So I'm going to divide each of these by 2x. So I get 2x equals to 5x minus 4. And each one of these factors has an x in it. And this one, you check your remainder for GCF. There's no GCF between 5x and 4, guys. So I'm going to take that 2x, because that factor has an x in it. I'm going to set it equal to 0. And I'm going to take that and set it equal to 0. Divide both sides by 2. I get an x of 0. Here, solve this 2-step. And divide both sides by 5 here. I get an x of 4 over 5 or 4/5. So my two x-intercepts are 0 and 4/5. You just got to try to get it set equal to 0. All right, I'm not going to move this. I'm going to move this. Move this one. Because if I move this one, I'm going to have to change this to negative. I don't want my leading coefficient to be negative. So I'm going to subtract 36 from both sides. Let's unstack these. So that's going to be x squared minus 36 equals to 0. Okay, check that for a GCF. There's no GCF between x squared and 36. So it's two terms. Check to see if it's a difference of two squares. Well, x squared is a perfect square and 36 is 2. So it is a difference of two squares. Now, if there had been a plus sign there, I couldn't do anything with it, because that's not a difference of two squares. That would have been a sum. But it is a difference. I'm going to take the square root of each. I end up with x and then 6. So I'm going to write this as the sum and the difference with the terms x and 6. I take these two factors and I set them both equal to 0. So here I would end up with an x of negative 6. So if I were to graph this thing, it would cross the x-axis at negative 6, and it would also cross my parabola. That's what they're called, guys. Would cross it at positive 6. So that U-shaped graph would cross it at negative 6 or positive 6 and positive 6. Now, keep in mind, we could have also written this as plus or minus 6, having two roots, two intercepts. One at positive 6 and one at negative 6. All right, some of these I think I'm going to skip because this is getting kind of long. I will show you that if you do this one, you need to subtract 9 from both sides. And there's no GCF, so this would be a difference of two perfect squares. And you should be able to go from there and solve. Not going to solve it. 15 though, let's work on that. I'm going to leave this x squared term over here because it's the leading coefficient. It's the one with my highest degree. Sorry. So my leading coefficient will be a 1. So because I don't want the leading coefficient to be negative, I'm going to move this stuff. So I'm going to subtract 4x from both sides. That's going to leave us with 1x squared minus 14x plus 49 equals to 1. Now I'm going to subtract 1 from both sides. So that will leave me with 1x squared minus 14x plus 48 equals to 0. Now I'm able to work this, and I got this easy one. It's an understood one. So I'm going to use the easy x. Now what gives me 48 and 14? 48 when I multiply. Let's go with negative 6 and negative 8. Negative 6 times negative 8 is positive 48, and negative 6 plus negative 8 is negative 14. So I can factor this with this being in my factors. So I'm going to take x minus 6 and set it equal to 0, and x minus 8 and set it equal to 0. So basically here I get an x that's equal to 6. Here I get an x intercept that's equal to 8. So my two intercepts are 6 and 8. My two x-intercepts, guys, for the parabola, the U shape. All right, let's take a look at 16. Well, you pause the video and try 16, but I'm going to tell you, 16 has a GCF in it, okay? So look for the GCF first. Okay, guys. The GCF is actually 3. If I divide everything by 3, you're going to end up with 3 times, in parentheses, the trinomial x squared plus 3x minus 4, all equal to 0. Okay? And then you're going to check your trinomial, your remainder, and see if it can be factored. Well, it can. And it can be factored using the easy x because the leading coefficient is 1. That would be 4 and negative 1. 4 times negative 1 is negative 4, but 4 plus negative 1 is positive 3. So I have 3, and then I'm going to use these because I'm going to use them in my factors because the leading coefficient was 1. I can do that. I don't have to bust up the middle. So that's going to be x plus 4 and x minus 1. I'm not going to use this as part of something that's set equal to 0. There's no x in it. So we're not going to highlight that. We are going to use this factor and that factor. So we're going to take x plus 4 and set it equal to 0, and x minus 1 and set it equal to 0. Here you get an x-intercept for the parabola of negative 4. Here for the parabola you get an x-intercept positive 1. And that's how you do it. Okay, let's get to one that's a little different. Let's take a look at 17. 17, you're looking for a GCF, but you don't see a GCF. The leading coefficient is not 1. It's a trinomial. So trinomial, the leading coefficient isn't 1, it's something greater than 1. So what I want to do is use the x where you rewrite the middle. So I'm going to be focusing on rewriting the middle with this x, okay? So if I rewrite the middle, I have to multiply a times c. 2 times negative 5 is negative 10. And b is 3, guys. So that would be 5 and negative 2. Yeah. I'm going to rewrite it this way, negative 2 and 5. But you're breaking up the middle. So that means 3x is negative 2x plus 5x. So I'm just going to bring these down. I'm going to break up the middle as negative 2x. And the reason why I put the 5 over here is so that the 5 can go with the negative 5 and the negative 2x can go with the positive 2x squared. Just matches up better. All right, plus 5x. So I broke up the middle. And then I just bring this down, minus 5, equal to 0. Now you have 4 terms, and I'm simply going to factor by grouping. These I'm going to group together, and these I'm going to group together, okay? So looking at the ones in green, I can see that they have 2x in common, which leaves me with x minus 1. Looking at the ones in purple, I see they have a 5 in common. So positive 5, and then which leaves me with x minus 1. Now I see the common binomial factor. The common binomial factor is x minus 1. I'm going to pull it out. And the leftover will be 2x plus 5. Take each factor and set it equal to 0. So here x is 1. And when you solve this two-step, divide both sides by 2. X is equal to negative 5 halves. 1 and negative 5 halves. And that is how you solve that one. All right, you're going to pause the video and try 18. There's no GCF, by the way. All right, it is a perfect square trinomial. You have 4x squared. The first term is a perfect square. 9 is a perfect square of the last term. If you take the square root of 4x squared, you get 2x. Take the square root of 9, you get 3. So if you take those two things and double them, if you take those two things and find a product and then double the product, you get 2 times 6x, which is actually 12x. So the middle term checks out as well. So it tells me that this is just 2x plus 3 squared, or 2x plus 3 times 2x plus 3. Now, if you didn't recognize that, you have to do it this way. So some of you may have done it this way. You may have used the harder x, where you multiply a times c and got 36. You still use the 12. So that would just be 6x and 6x to break up the 12x. So some of you may have done that, and you brought this down. 4x squared, break up the middle, positive 6x, another positive 6x, and then you brought that down. Some of you may have factored by grouping. If so, then that's absolutely fine, because you can factor a perfect square trinomial by using the a times cx and then factoring by grouping. All right, I'm going to group these two together, and then I'm going to group those two together, guys. So I see the first two have 2x in common. So that's going to be x plus 3 left over. And then the two in blue all just have a 3 in common. And that's going to leave me with 2. Oh, I missed something right here. 4 divided by 2. 4 divided by 2 is 2. So that's 2x plus 3. And then 6x divided by 3 is 2x. 9 divided by 3 is 3. So the common binomial factor is 2x plus 3. And the leftover is 2x plus 3 as well. And it's all set equal to 0. So you could have done it this way or this way. I don't care which one. Okay? But either way, you're going to take 2x plus 3, only use it once, set it equal to 0 because it's the same factor, guys. So we get 2x equal to negative 3. Divide both sides by 2. And you get an x-intercept of negative 3/2 for the parabola. Okay, 19, you got to do a little work to get it equal to 0. So let's take a look at 19. I'm going to move this one because if I subtract 1 x squared from both sides, it won't make my leading coefficient negative. It'll be positive 4x squared. Plus 7x equals to 2. Now I just need to subtract 2 from both sides. And these aren't matches, so I'm just going to write this. They don't match this, that negative 2. So I'm just going to write this back down or unstack it as 4x squared plus 7x minus 2 equal to 0. And there's no GCF, so I'm going to have to use the harder x. Okay, 4 times negative 2 is negative 8. Keep my 7. That's 8x and 1x. Or negative 1x, guys. 8, and you don't have to put the x. I just have a habit of doing it. Some of you may just like to keep it like this. 8 and 1, negative 1. Well, you have 8 times negative 1 is negative 8. 8 plus negative 1 is 7. But I still need you to remember that you're breaking up the middle term. So these actually become part of the middle. They bust up the middle. So plus 8x minus 1x, and then here minus 2 equal to 0. And I am going to keep these together and keep these together, okay? So I'm going to divide by 4x here. That's a GCF between those two, which leaves me with x plus 2. And here I'm just going to factor out the negative 1 because that's all they have in common, which leaves me with x plus 2. And I can see clearly they have a common binomial factor. The common binomial factor is x plus 2, and the leftover is 4x minus 1. So I'm just going to take each one and set it equal to 0 and see what my parabola when it was graphed, or if I graphed it, would cross the x-axis. Divide both sides by 4, and x is equal to a fourth. So my two x-intercepts for that parabola, if I graph, will be -2 and 1/4. All right, I was going to teach you how to use the square root method, but let me see how many I have. Whew, too many. I think right now that's enough. That's about all. That's as much as I can expose you to at the moment. That's going to help you with Algebra 2, guys. I wish I could have gotten more into solving, but your Algebra 2 teacher will go back through this unit again. It's also a part of the Algebra 2 course of study, so you're going to get it again, okay? All right, thanks, guys.